I wanted to welcome you all on the energy panel. So, empowering energy, OT strategy, OT security strategies, and in today's digital age, energy infrastructure faces increasing threats from targeted attacks, ransomware, and sophisticated malicious actors. The rise of interconnected IoT system has brought about new vulnerabilities that energy companies must identify and assess to ensure the security and resilience of their operations. And so get ready to dive into the world of OT security in the energy sector and empower energy companies to protect their vital infrastructure from evolving threats. And together we can build a secure and resilient future for the energy industry. And I wanted to introduce my guests. Maybe introduce myself first. My name is Dorota KOZLOWSKA, and I'm a penetration tester, so I work on the red side more, but I'm here to moderate this panel. So, and one of our guests, Gregor, is replaced by someone else. So that's Gregory Dupois. And to give him a short demo about Gregory, he's the head of marketing and sales European Union at Framatome Cybersecurity, embodies the nexus between technical innovation and the demanding cybersecurity market. His 10-year entrepreneurial journey in software publishing, enriched by diversified roles in sales and marketing, as Inclusive Networks, Autorio, and most recently Framatome Cybersecurity, grants him a profound understanding of the sector's dynamics. And I asked my guests to give me like a fun fact about them or like hobby. So his hobby is DJing, and he's also a certified scuba diver. The next guest is Andrew GINTER. He's the VP of Industrial Security of Waterfall Security. Andrew is the VP Industrial Security at Waterfall Security Solutions. He leads a team who works with the world's most secure industrial sites. Before Waterfall, he developed software used in power plants and pipelines. He developed middleware product that connected IoT and OT. IT and OT networks together, has contributed to cybersecurity problems that now plague many industries. And his private note is, in his spare time, Andrew also writes, and his work of fiction called Don't Jump in the Haystack is a book that was a gift to his daughters, and it's a collection of bedtime stories. The next guest is Pierre OGER, and he's founder of OGER. I hope that I pronounced that correctly. Pierre has been a technical organizational and regulatory expert for cybersecurity for many years. Today he assists the major corporate and government departments in the consideration of cyber risk and the implementation of a global cybersecurity management system. Pierre is a member of several cybersecurity and risk management trades federations such as SACHS, of which he is a VP and member of the board of directors. And a personal thing about Pierre, he's an Argentinian tango dancer and a jazz guitarist. And then another next guest is Marc SACHS. He's the Deputy Director for Research Auburn University, McCraney Institute for Cyber and Critical Infrastructure Security. Marc is a Deputy Director for Research at Auburn University, McCraney Institute for Cyber and Critical Infrastructure Security. He is a retired U.S. Army officer and was a White House appointee in the George W. Bush administration. His private sector experience included serving in the Deputy Director of SRI International Computer Science Laboratory, as a Vice President of National Security Policy at Verizon Communication, as a Senior Vice President and Chief Security Officer at the North American Electric Reliability Corporation. And he holds degrees in civil engineering, computer science and technology commercialization, and as a licensed professional engineer. And like his personal thing is, yeah, that's my favorite actually. But he's a collector of mechanical encryption devices that go back to the early 1900s. His collection includes some cool items such as Enigma machines and recovered key sheets from the sunken U-boat. And in the spare time, he's also a truck repairman for a local heritage railroad. So yeah, those are my guests. And my questions. First, I wanted to ask an open question. I recently read a report titled Anatomy of 100 plus cybersecurity incidents in industrial operations, a research study with recommendations for strengthening defenses in OT ICS, and phishing was cited as the most popular attack technique, that was like 34%. Other common access vectors include external remote services, 19%, replication through removable media, 13%, remote services, 11%, and supply chain compromise, 8%. And my question is, what makes those vulnerabilities specific to the energy sector? And like, maybe if anyone wants to answer this question.
Testing? So yes, let me start. I'm a co-author of a similar threat report from Waterfall. In that report, we looked hard at ransomware and at how ransomware could affect physical operations, shut off the lights, stop the trains running, this sort of thing, and concluded that there were maybe 3.5, maybe 4 ways that ransomware could do it. Ransomware could target the OT systems directly. Might get into there through remote access, might get into there through some other mechanism. That's the obvious. You know, the Snake ransomware has code in it to shut down operations. It shut down Honda, I think, at least twice, possibly 3 times, by getting into the manufacturing systems. The second way that ransomware can shut down physical operations is the Colonial Pipeline scenario, abundance of caution. It gets into the IT systems. The people responsible for operations look around and say, we have a safety critical system here. We don't know if that ransomware, if that malware is going to leak into our system. And so they shut down physical operations, in case the ransomware gets in there. So never actually got in there, but shut it down anyway. And the third way is dependencies. And the classic example is Maersk Shipping with NotPetya back in 2017. The ransomware crippled the IT network, crippled the Active Directory server, and so the system that tracked where the containers were supposed to go was crippled. The ship's navigation systems were fine. They still came into port. The cranes, the computers controlling the cranes, could still lift the containers off the ships and put them on the trucks. But nobody could print the labels to tell the truck drivers where to take the containers. And for 6 days, container shipping, the world's largest container shipping company, stopped processing containers because their physical operations depended on an IT system that had been crippled. And the fourth way, if you're curious, is dependencies intercompany. I don't know if it's really a fourth way. Ransomware got into one of Toyota's suppliers, crippled production in the supplier through one of the 3 ways, I forget which it was. But then all of Toyota shut down. Their entire supply chain shut down because the Toyota factories could not keep going without these just-in-time supplies. And so Toyota was shut down by somebody else's ransomware. Is that a fourth way? I don't know. But if you're talking about how can a phishing attack affect operations, cripple IT, and shut down either in an abundance of caution or because of a dependency.
And I'll add on to that with phishing. If you remember the attack in December of 2015 in Ukraine, in Kiev. So that started with a phishing incident about 6 months earlier. The criminals were able to gain a toehold into one of the Oblenergos, one of the energy companies. From there, they were able to steal usernames and passwords on the IT side. And they started guessing that these usernames and passwords might work for remote access on the control side. And in fact, they did. And so this was a mistake made by those companies that they were reusing the same username password. And so if an adversary can get in on the IT side and your best practices aren't right, they might be able to replay that same attack on the other side, on the control side. And then once they're in, then it's a matter of just turning things on and off, what happened. To their credit in Kiev, they were able to go into manual mode, they were able to restore, bring it back up. And to their great credit, within about an hour of that attack happening, they had a notice on their website that says we're down because of a cyber incident. I've never seen another power company do that. And then they were very public about what was going on, explaining what was happening. I would challenge any North American power company that transparent during a cyber attack and keeping people up to date. That seems to be a challenge for all of us.
Yeah. So my next question is for Gregory. What is the ever-evolving efforts to keep the electric grid secure? What are the ever-evolving efforts to keep the electric grid secure?
Donc le sujet de la maintenance en conditions de sécurité des assets industriels et particulièrement des assets qu'on retrouve dans l'environnement électrique est fondamental puisque, vous le savez probablement, on est amené à travailler sur des assets qui ont des durées de vie extrêmement longues et dont les contrats de maintenance sont régulièrement prolongés. Et donc la gestion de la vulnérabilité et des mesures de gestion, de mitigation du risque de ces assets qui sont posés pour des décennies pour certains d'entre eux, nécessite une organisation particulière, déjà une stratégie de type défense en profondeur lorsqu'on déploie ces outils à l'intérieur de l'entreprise, à l'intérieur de l'opérateur, mais aussi une people process product, donc une combinaison d'actions qui permettront de les maintenir dans un état qui leur permet d'éviter d'offrir trop de surface d'attaque, sachant qu'effectivement la complexité de ces systèmes, qui sont souvent qualifiés et donc qui nécessitent d'être supervisés par les autorités pour certains, est un enjeu fort s'agissant de la gestion des vulnérabilités et des patchs qu'on est capable de déployer ou des mesures de contournement pour assurer la sécurité de ces équipements sur une durée très très longue.
Pierre, I have a question for you, and my question is: what are main challenges of energy sector IT security in Europe?
Alors nous, notre positionnement avec notre technologie, notre plateforme en fait Egeri, c'est de nous positionner sur la prédiction des risques cyber. Et donc il est important on a beaucoup parlé en fait de scénarios d'attaque, d'incidents, de vulnérabilités associées. Nous, notre positionnement, c'est vraiment d'être dans l'anticipation du risque cyber. Alors la vulnérabilité, c'est un des moyens de construire un scénario de risque, mais il y en a plein d'autres. Et il y a une difficulté aujourd'hui sur le marché, et entre autres sur le marché de l'énergie, c'est d'être capable à la fois de centraliser l'information des risques qu'on connaît, mais aussi en même temps de pouvoir travailler à la prédiction des risques. Pour ça, il y a des méthodologies qui existent, qui s'appellent des méthodologies d'analyse de risque, et basées sur ces méthodologies qu'on est capable d'outiller, entre autres avec notre technologie, on peut de façon systématique centraliser ces informations pour pouvoir petit à petit avoir une maîtrise complète au travers d'une cartographie de vos risques et ensuite pouvoir travailler sur des plans de remédiation et donc d'aider à la mise en place des meilleures mesures de sécurité dans le but de protéger la situation à risque qui est connue sur le secteur de l'énergie. Il y a un enjeu très fort aujourd'hui aussi en cybersécurité et donc sur la cybersécurité de l'énergie, c'est la problématique de l'investissement cyber. Pourquoi ? Parce qu'on n'aura jamais assez d'argent pour pouvoir traiter l'ensemble des vulnérabilités. C'est ce que montrent d'ailleurs les incidents qui ont pu être décrits par les autres intervenants de cette table ronde. Et donc, il y a un vrai besoin d'optimiser les défenses, d'optimiser les investissements qui sont faits pour mettre en place ces systèmes de défense et donc d'être capable de mettre en place un système qui permet de prendre ce type de décision. La proposition qui est faite par notre plateforme, c'est de travailler sur l'appréciation des risques et à terme de mettre en place les meilleures défenses.
Thank you. Andrew, my next question is for you. So, what are the most important recent developments in OT security for the energy sector?
So, to me, something I've been tracking very closely is cyber-informed engineering. I'm a conservative person. I don't often use the word excited, but I am excited about what I see in cyber-informed engineering. What is it? Let me say first, looking at the numbers of cyber attacks that shut down physical operations, last decade, 2010 through 2019, it was flat. It was almost zero. In the last 3 years, it's increasing exponentially. If that trend continues, that's a crisis coming down the tracks at us. I do not believe we can build a cybersecurity wall that's big enough or strong enough to stop that train. Cyber-informed engineering gives us a way to step off the tracks. Cyber-informed engineering positions managing physical risk due to cyber attacks as a coin with two sides. One side is cybersecurity. Teach cybersecurity to engineers. We've been saying this for 20 years. There's nothing new there. The other side of the coin is engineering. What does that mean? A classic example, safety engineering. If each of your lives depended on a boiler not blowing up in your face because you worked with that boiler or 6 boilers like it all day long, if your life depended on a boiler not blowing up, how would you prefer to be defended from a cyber attack that targets the furnace under a 5-story boiler? Would you prefer a mechanical valve where if the pressure in the boiler is too large, the valve is forced open and the steam escapes and there can be no explosion because there's no pressure anymore? Or would you prefer a longer password on the computer controlling the furnace? Most of us would prefer a mechanical valve, or 3, because these things do wear out. Here's the thing. Where is the mechanical valve in the NIST cybersecurity framework? It's not there. Where is it in ISO 27001? It's not there. Where is it in the industrial 62443? These are all cybersecurity standards. The mechanical valve is an engineering mitigation. The engineering community has very powerful tools to manage physical risk, and these tools have not been used systematically to address cyber risk in addition to physical risk. And this is what the Cyber-Informed Engineering Initiative is part of. Yes, teach engineers about cybersecurity and start using systematically, universally, these powerful engineering tools to address cyber risk in addition to other risks.
Let me add on, because I also am excited about CIE. I share the same passion. So in the engineering schools, we have a challenge with mechanical engineers, electrical engineers, civil engineers, environmental engineers. They look at cybersecurity as an IT problem. We have a computer science department. They teach cybersecurity. That's their problem. I need to worry about the physics of engineering. I need to build things that will stand up. I need to build things that won't explode. I need to build things that won't shock somebody if you touch the wrong place. So the thinking now is, let's teach those engineers how to look at cyber as a peril, something that could make their beautiful engineering design fail, and can they use engineering principles and practices to perhaps rethink engineering so that if it does fail, it fails in a controlled manner. much like you would do with a wind load on a building, or floods in a basement, or fires, or any other peril that you think about as an engineer. Consider an adversary trying to attack a trusted computer system. What's the worst that could happen, and can I engineer to prevent that from happening, or if it does happen, could I engineer a way for it to fail safely when controlled? It's a different way of thinking, and we're seeing a lot of not only universities but also enterprises and businesses beginning to rethink this. So we love this idea, and the work you've done on it, Andrew, is phenomenal, and we're just going to keep making it better. I think this is the new way now to approach security, particularly in the OT community.
Yeah. And Marc, don't keep that mic in your hand, because next question is for you. So in recent years, cybersecurity of critical energy infrastructure, electric power, natural gas, petroleum and petrochemicals has increased significantly. The bad guys know this, which is why they are now attacking the soft underbelly of the CAI, the supply chain. How can energy companies protect their critical infrastructure from supply chain threats?
Thank you. And I had to put the headphones on because I can't hear you with the noise. Now, good question. And I think the risks against the energy companies, previously, when you weren't connected to the internet, this goes for almost anybody, risk was something you could manage inside. With this increased connectivity, the risk now expands globally. So you can have, instead of physically going up to some electric plant, pump station, water supply, whatever, have to physically touch it, now I can touch the other side of the planet. There are adversaries who would love to just cause damage. There are certainly many that would like to steal money. That's the ransomware problem. And they will go after a power company, a water company, a forestry company, anybody, if you have money. And they'll do it with a different mindset of trying to attack and do damage. We do spend a lot of time worrying about the damage side. We talk about this a lot. What happens if the grid fails? What happens if airplanes fall out of the sky? We also need to rethink this financial side. What happens if a company gets held for ransom and they can't operate? This is not really a technical failure, it's more of a business failure. That intersects with all of our old thinking about protecting the infrastructure. So I think with the connectivity piece, that's really what's beginning to hurt us. Also on the vendor side, many of our new devices, they all want to talk to the internet because they want the vendors to do remote updates and remote patching and remote maintenance. Anytime you have remote something over the internet, that's a whole nother vector for attack, and our adversaries know that. And they'll use any method they can to mess with our systems.
Oui, je pense qu'il faut globalement repenser le système de défense de l'univers, en fait, de l'économie et de l'industrie de l'énergie. Il faut être réellement conscient de la puissance des attaques qui peuvent être réalisées aujourd'hui, et donc il faut être capable d'anticiper les risques et les impacts qui sont associés. Ça veut dire, si on fait un parallèle en fait avec la défense nationale, quand dans des systèmes de la défense nationale le niveau de risque est trop élevé, on est capable de désactiver en fait la mise en place du service. Donc je pense qu'on va arriver à terme à des systèmes d'industrie de l'énergie qui seront capables de désactiver le mode opérationnel du système. Et puis je pense qu'il faut aussi beaucoup travailler sur la capacité de redondance des systèmes, aussi bien en termes de fourniture d'énergie, mais aussi de distribution, parce que on a un enjeu important en énergie, mais en fait c'est en alimentation en énergie aussi où on a un enjeu qui est très important. Et donc il va falloir être capable de construire des systèmes en parallèle qui permettent du coup de délester, jusqu'à présent il était utilisé pour délester les systèmes de fourniture d'énergie, mais potentiellement il pourrait être aussi utilisé pour redonder les moyens d'alimentation de ces sources d'énergie. Donc il y a vraiment toute une réflexion globale à mener sur la situation de crise et la gestion de l'énergie au travers d'un élément concret qui est que le risque cyber sur ce secteur est extrêmement fort et il doit être pris en considération dans ces études pour l'évolution aussi des services apportés par l'énergie.
Je rajouterais peut-être 2 mots pour revenir sur le concept de défense en profondeur. J'entends ce que vous dites sur l'augmentation des risques. Effectivement, ici, tout le monde est d'accord sur le constat. Pour autant, les stratégies, pour moi, n'ont pas évolué dans le sens où les stratégies de défense en profondeur existent avec des diodes, avec des systèmes d'isolation. Simplement, aujourd'hui, la surface d'attaque, elle augmente. Donc, on doit considérer de manière plus fine la manière dont on adresse la défense en profondeur dans l'énergie. Plus fine, ça veut dire qu'effectivement, maintenant que c'est connecté, les vecteurs d'attaque sont plus présents. Donc, on doit mieux gérer les vulnérabilités et on doit mieux gérer les programmes qui nous permettent de patcher ou de mitiger les risques. Ça veut dire que malheureusement, dans l'OT, on le sait, c'est extrêmement vaste les vulnérabilités, c'est extrêmement compliqué d'aller patcher des systèmes en production. Et donc, le sujet, et je rejoins Pierre, c'est la prioritisation du risque parce qu'on ne peut pas tout faire. Et donc, il faut savoir qu'est-ce qui est vraiment important, par quoi je commence et comment j'exécute mes programmes de mitigation, toujours dans un esprit de défense en profondeur. Ça, je pense que ça n'a pas changé en fait, mais simplement il faut être plus efficace. Et je rajouterais, Pierre, la régulation aussi aujourd'hui est de plus en plus contraignante. Et je sais que des outils comme le tien permettent de suivre la manière dont on va adresser la régulation au sein de nos entreprises d'énergie, parce que ça devient assez complexe. Et pour des entreprises multinationales d'énergie, eh ben, on a X régulations à adresser et on a besoin d'outils, on a besoin de priorités. En fait, on n'a pas beaucoup de bras, vous le savez, on a des problèmes de people. Donc c'est cette combinaison qu'il faut qu'on soit effectivement efficace, que tu avais dit tout à l'heure. Voilà pour mon point de vue.
And let me add, cyber-informed engineering is positioned as a coin with two sides. It's not that we pick one side or the other. We don't choose one side or the other. We use the whole coin. The sites that I see, and you know, Waterfall works with the most cautious sites on the planet. The sites that I see using the engineering approach the most intensely also use defense in depth and cybersecurity most intensely. The question is not which side of the coin do we use. We use the whole coin. The question is how high do we put the bar? And we set the bar at a different height for a small shoe factory as we do for a high-speed rail switching system. If you're interested, if I might do a 20-second plug, this is the topic of my brand new book, Engineering Grade OT Security. It releases next week. I have pre-release copies at the CISE booth beside the yellow stage. If there's any left, I'd be happy to have you guys come by and take the complimentary copies away.
Yeah. Pierre, my next question is for you. So OGER is a leading publisher of cyber risk management solution in Europe, recognized by European authorities. OGER's collaborative approach and smart technology help customers centralize and coordinate their cyber risk assessment strategies, identify high risk and threats, measure the results of risk mitigation efforts, and gain support from all levels of their organization. Can you tell us something about OGER's solution?
Oui, évidemment, oui. Avec plaisir. Donc, comme je le disais, en fait, on est une plateforme collaborative qui permet aujourd'hui, avec 3 grandes fonctionnalités, mais le sujet, c'est la pertinence de vos investissements en cybersécurité. Pourquoi ? Parce qu'on est capable, dans notre plateforme, de mettre en parallèle le montant de vos investissements au travers des mesures de sécurité qui vont être mises en place. Et de l'autre côté, la réduction du risque associé par rapport à la quantification financière de l'impact. Et qu'est-ce qui lie en fait ces deux mondes, l'impact d'un côté et la mesure de sécurité ? Eh bien, c'est le risque cyber et pas la vulnérabilité. Je vous invite vraiment à faire attention à cette nuance. En fait, le marché parle beaucoup de vulnérabilité et on confond l'information de vulnérabilité et de risque. Là, moi, je parle bien de risque cyber. Donc, notre plateforme, elle est capable de donner cette approche aux directions générales, aux managers des très très grandes entreprises, avec une présence, on est leader sur le marché français sur ce sujet. Et comment on est capable de démontrer la qualité de ces informations ? Eh bien, par 2 vecteurs. Le premier, c'est l'ingénierie de l'identification des risques cyber au travers d'une première fonctionnalité de notre plateforme. en mode collaboratif et en mode structuré et multiméthode. Et puis au-dessus de ça, un outil d'aide à la décision qui permet donc d'accompagner nos décideurs dans la prise, donc principalement en fait les gestionnaires des risques dans les très grandes entreprises, de les accompagner dans la prise de décision des meilleures mesures pour pouvoir réduire les risques qui ont été sélectionnés et à partir de là de pouvoir définir des plans d'action et ensuite de remonter à ce niveau de quantification financière. Voilà. Donc c'est une plateforme qui est unique dans son genre, puisqu'on est les seuls en fait à avoir réuni dans la même plateforme ces 3 niveaux de présentation de stratégie de cybersécurité, et qui est aussi unique dans l'appréciation de la prédiction des risques cyber. Un seul chiffre pour que vous ayez conscience de la réelle problématique de cybersécurité: 35% des cyberattaques pendant la période du Covid étaient liées à des nouvelles technologies. Ça veut dire quoi? Ça veut dire que dans un monde qui s'ouvre au travers de l'évolution des technologies numériques, on a face à ça une explosion en fait croissante de la problématique de construction et de l'ingénierie de construction des cyberattaques. Et à partir de là, si on n'est pas capable, en opposition de ce niveau de performance des attaquants, de s'amuser entre guillemets à prédire des scénarios d'attaque pour pouvoir en construire les défenses, il est clair que les attaquants qui sont en face de nous arriveront toujours à nous terrasser. Et c'est tout l'enjeu en fait, c'est de réussir à devenir des combattants du système de défense de la cybersécurité, au travers de quoi? D'une capacité à prédire des scénarios de risque et ensuite à travailler sur la concentration de cette information en un seul point dans l'entreprise pour construire petit à petit un actif de cybersécurité.
Thank you. Marc, the North American power grid covering all of the USA and Canada as well as portion of Mexico is the largest machine ever constructed. To control and balance such a complex system requires plenty of computing power and necessary exposure to external threats. What are the examples of specific grid security techniques and tactics?
Sorry for the delay. If you don't know, Canada, United States, Mexico, we've got 2 major grids. There's an eastern grid and a western grid. So Canada and the United States share an infrastructure. Texas has their own, Quebec has their own, Alaska has sort of a grid. Mexico is building one. They would like to connect also. We're telling them, be careful, you may be better off staying independent. But it winds up being the largest machine ever. So this is a mechanical electrical machine, literally in Miami, Florida, all the way up past Ontario and up into the northern reaches of that province. You have generators spinning in sync with each other. It's an absolute amazing machine we've made. So a disruption anywhere in that machine can propagate and transmit across that machine literally within seconds. So there are safety mechanisms, of course, built in. When we saw the big power outage about 20 years ago, it started in Ohio, made it up into Canada, made it over to New York. It was contained not as quickly as it should have, but at least it didn't spread further south or further west. With cyber attacks against this type of mechanical machine, if an adversary were to do it right, they could launch attacks across multiple parts and try and mess with the phasing. Because remember, this is an electromechanical machine. So if I was a bad actor, I would look to try and get it out of phase to where the machine tries to go into emergency mode, begins opening up itself, popping all these breakers to self-protect. Then I'd leave it alone, let everything reattach, try and get the power. Then I go back in again. And I would do this over and over until the asset owners are on their knees and they're begging for mercy. Now, I'm not trying to tell you how to crash the grid, but if I was a bad guy, that's how I would do it. Keep in mind, I'm describing the North American grid. Europe works the same way. Asia works the same way. Australia works the same way. So an attack that might work someplace else could play out here because we're all using the same machinery, the same infrastructure. There's some differences in terms of the way we've mechanically built it, but as we get more and more automated, there's very few companies that make these systems, the computer controllers and others, and so we have just a few weak links. And if I can find that weak link, I can apply it in many, many places.
You've described the problem. What is the solution? And to me, the solution has many parts. But again, one of the parts I'd want to emphasize is the opportunity to apply engineering tools to this. And the technology is currently highly engineered and highly cyber secured, but the engineering discipline for addressing cyber risk really has not been applied systematically, and I think this is an opportunity. And it does not necessarily, not all of the solutions exist at this point. So personally, one of the things I worry about is that protective relays, which are the devices that prevent damage to high voltage transformers and to rotating equipment, these are all software. All software can be hacked. All software has vulnerabilities. To me, one of the big opportunities is to, what's the right word, crystallize that software as a chip, as an ASIC, because these are static functions. And if you were to crystallize that software, you would suddenly make it much more difficult to damage any equipment in the grid. An attacker might still be able to cause a short-term outage for an hour, but if the way to cripple the grid is to damage the equipment. So, to me, the opportunity here for innovation is to take the current generation of protective relays and harden them into hardware rather than software.
Gregory, you mentioned before defense in depth, and it's quite an old concept, but is it still relevant in 2023?
Oui. Pour reprendre ce que je disais tout à l'heure, effectivement, on pense qu'il faut finalement garder le concept, mais on affinait les stratégies d'application. Chez Framatome Cybersécurité, on a développé un programme qui vise justement, d'une part, en s'interconnectant avec des logiciels tels qu'EGERI, à détecter les vulnérabilités selon les différentes couches, et chaque couche du modèle Purdue va nous donner un niveau de criticité différent et donc un niveau d'action et d'opération à exécuter plus ou moins rapidement. Là encore, la difficulté, c'est par quoi je commence. Et en classifiant les vulnérabilités dans un contexte business et safety, on arrive à retirer du bruit et à se concentrer sur des programmes de patch management qui vont permettre d'avoir un impact rapide parce qu'on a fait une sélection drastique des assets critiques et qu'on les a mis en perspective sur les risques business tout en conservant ces stratégies de défense en profondeur et donc en analysant cela selon les couches du modèle qui nous permettent d'organiser cette stratégie de réponse avec des programmes qui fonctionnent sans être trop ambitieux. L'idée là encore, c'est d'être extrêmement efficace.
Thank you. Andrew, you mentioned cyber informed engineering. Can you dig deeper and tell me as well how can TIE protect reliability as well as safety?
Sure. I mean, the example I gave a couple of times is, I gave the example of safety engineering, the boiler blowing up, protection engineering. But think about it. Let's think about old school coal-fired power plant, 6 boilers, massive devices. When that mechanical valve engages and we avoid an explosion, what happens? Well, the good thing is there's no explosion. Nobody died. This is good. But when that valve engages, we turn the power plant off because this is never supposed to happen. This is an unsafe condition. And we will not turn that power plant back on until we understand why that condition occurred and we take measures to make sure it never happens again. This can take days, it can take weeks. Here's the problem. A power plant that big, 9 times out of 10, is critical infrastructure. It's critical to national security. This is what critical means. Critical means critical to the nation. And so we don't want to turn it off. how can we avoid turning it off? You know, the engineering mitigation that nobody died is great. We also need engineering mitigations to prevent compromise in the first place. And to me, this is where network engineering comes in. Think about it. We're talking about preventing cyber sabotage of physical operations. The only way that a control system, an industrial automation system, can change from a normal state to a compromised state is if attack information somehow enters the system. 9 times out of 10, it comes in through the network. The rest of the time, it's, you know, USBs and whatnot. So network engineering, information engineering, is a set of tools that that are used to control the flow of information that might contain attacks. I mean, in the business world, we need to protect the information. This is what we do. In the OT world, we need protection from information because all cyber sabotage is information. If you look at the problem the right way, the answers become self-evident. If we start asking in the industrial world, how do we protect the information, you get nonsense answers. We're not trying to protect the information, we're trying to keep the lights on and protect reliable operations from attacks that may be embedded in incoming information. And you know, this is chapter 5 in my new book, Network Engineering. None of these techniques are very new. A lot of these engineering techniques are old. What's new is the perspective, is looking at using these techniques to systematically address cyber risk in addition to other kinds of risks they've long been used for.
Ouais, je trouve que ce qui est intéressant dans le secteur de l'énergie, c'est la complexité technique à laquelle on doit faire face. Comme vous l'avez dit, hein, il y a des technologies qui sont très anciennes, parce que comme tu l'as dit aussi, ces technologies, elles doivent durer très très longtemps. Les systèmes industriels, on ne peut pas les modifier. Vu le coût d'investissement, on ne peut pas les modifier régulièrement. Néanmoins, tous ces systèmes, ils sont de plus en plus ouverts et donc du coup, ils sont plus sensibles à la problématique de cybersécurité et en même temps, ils sont en production. Donc oui, le système de défense en profondeur, il est clairement indispensable parce que ça permet de mettre en place une multitude de barrières et donc du coup de traiter la problématique que la cybersécurité n'a pas été prise en considération au moment de la production de ces outils, mais extrêmement spécialisés, qui n'ont pas forcément un niveau d'expertise en cybersécurité qui est important. Et pourtant, il va falloir adresser cette problématique et l'adresser là d'une façon encore plus efficace. Pourquoi ? Parce que tous ces systèmes automatiques, ils sont connectés de près ou de loin à un système de type Internet pour pouvoir, par exemple, faire du contrôle en temps réel, des mises à jour et ainsi de suite. Donc, il y a la cybersécurité, c'est avant tout trouver des solutions dans un environnement technique qui est un vrai challenge, mais ce challenge technologique, il est beaucoup plus fort sur l'environnement de l'énergie.
Let me add, we do have an opportunity. We have new energy systems, wind, solar, green energy, distributed energy. There's opportunity there to actually do it right. So rather than having to go back to old systems that predate the cybersecurity problem, are we looking forward and are we demanding that those who are building these new energy systems, all of them are computer controlled? Unfortunately, all of them depend on the internet to be managed. Are we taking that into account? Are we setting us up again for more failure because we're not recognizing this could be just engineered in from the beginning? And I think it's a big opportunity, a way ahead as we continue to retrofit, rebuild, add on to the existing power grid.
But let me add to that. I agree with what's been said here, but think about it. Imagine that we had a magic wand, and we could wave that magic wand and instantly bring all of our electric sector or other, critical infrastructure, automation systems right up to date. The latest version of the operating system, the latest version of the software, completely patched, long passwords, encrypt everything. Imagine we had that magic wand. We would still need to manage the automation systems differently than we manage the IT systems. Why? It's because of consequence. All of these differences, or not all of them, I mean, some of the complaints here are legitimate. Some of the difficulties in managing today's OT systems is just inertia. Okay, the engineers need to get it. The cybersecurity side of the coin, that message needs to reach the engineering teams. Yes, there's some inertia. But even if we had that magic wand, fundamentally the difference is consequence. What is the worst that can happen if every CPU in the industrial network executes the wrong instruction? Well, things blow up, people die, the lights go out. These are all unacceptable physical consequences. What's the worst that happens on most business networks if every CPU executes exactly the wrong instruction? We leak personal information into the internet. We get sued. We have to bring experts in. It takes 10 days. We pay through the nose. It costs us millions of dollars to clean up the mess. All told, in a medium-sized business, it might cost $3 million. It might cost $20 million. We can buy insurance for that. All the insurance we buy won't help us if trains collide and hundreds of people die. You cannot buy insurance for that kind of event. And so even if we could wave the magic wand, the fundamental difference would remain. And I submit that even if we did the new systems correctly, in 5 years' time, because we have to manage those systems as reliability critical or safety critical, some of these difficulties would come back, because you have to manage the systems differently. You cannot change safety critical systems when Microsoft issues a new patch after testing it for a day. Someone's going to die, and that's unacceptable.
Yeah. So as a red teamer, I have one more question because I was allowed to go a bit over time. So my last question is my personal interest, and so targeted attacks, ransomware, and sophisticated malicious actors are growing threats to energy infrastructure. How can energy companies identify and assess the vulnerabilities of their IoT systems? And that's an open question, anyone can answer.
So it starts with, and many people have recognized this, knowing what you have. I mean, it sounds kind of basic, but for those companies who don't know what they have, they don't know what to secure. So a good inventory of what you have. And that includes operational side, as you mentioned, Andrew, connections that you have, the employees that you have, the vendors that you have, the supply chain, many, many ways that a bad actor can get into a sensitive, critical system. And I only bring this up because often that first step is missed by many organizations. They want to hop right into patches. They want to hop right into new software, whatever, but they don't even know what they own. Many years ago when I worked at Verizon, this was one of the things as we did investigations, we would often find that our customers did not know they had a certain router. They did not know they had a certain data system. Didn't know they had a website. Didn't know, and that's where the breach happened. These assets they didn't know they have. So you have to start with understanding what you have and then build from there.
Yeah.
I agree completely, but let me say as well, there's a difference between, again, a small shoe factory and a high-speed rail switching system. In a small or a medium-sized shoe factory, we see industrial internet connections all the time. A large factory, this was 6-7 years ago, I was talking to experts in the field. They were saying we have 60 or 70, nearly 100 kinds of connections to the internet from the factory floor. Okay, the industrial internet is here. But in a factory like that, when the worst case consequence of compromise, if every CPU does exactly the wrong thing, if the worst case is a business consequence, it costs us $30 million, again, we can buy insurance for that. Do some encryption, do some zero trust, and keep going. When the consequences are unacceptable is when we need to start getting inventive. If we want, and we do, we want the economic benefits of the cloud in our power plants and in our rail switching systems. If we want those benefits, we have to be much more cautious. I recommend to you a methodology that EPRI, the Electric Power Research Institute, put out some years ago, talking about how can you safely connect the most critical power systems into the internet to benefit from predictive maintenance applications. And one of the tools they said is when you've got your sensors, make sure they're truly sensors, not controllers. make sure they're sensors, put them on your turbines, put them on whatever you need to measure, and do not put them on your industrial network. Put them on the internet. Put them on a DMZ on your IT network. Send your data straight out to the internet. If you compromise those sensors, what's the consequence? Now it's a business consequence. You maintain your equipment inefficiently, it costs you a few $1 million extra. Again, something you can buy insurance for. If you ignore that advice and you put the sensors on your OT network, your control network, now a worst case attack compromises the cloud, changes the firmware, and you're done. It's over. So there are ways to do this. No engineering team on the planet has increased connectivity with the internet as a goal. They have efficiency improvements as a goal. And here's the thing, almost all the time, almost all of the benefits can be realized without incurring unacceptable risk.
Thank you. This concludes our panel, and so I wanted to thank our guests for speaking and presenting and sharing their ideas with us. And thank you for being here and listening to our conversation. And thank you for also being on the conference and yeah, that's it.